Good morning. Everybody awake? Good. That's what we want to hear. So let's see what we can do about errors and why they always happen in the worst possible moment. So my talk is called Why is it always DNS, TLS, and bad configs? And when I built that talk, like what I had in my mind is maybe you remember Harry Potter. And there were always these three. When something bad happened, it was always these three. There was this scene where McGonagall asked, like, why is it always the three of you? And while they didn't do all the bad stuff themselves, they were always good indicators that something was up. And this is kind of like how I see DNS, TLS, and bad configs, or maybe you want to add printers to that list. But printers are also like a classic. But we'll focus on like the DevOps tooling more. So it's these three things, and we want to look at like, why is it always these three and what can go wrong? So let's start with DNS. And I picked two examples each of what could go wrong. So here it was Akamai, which went down, I think, a bit over a year ago because some bad DNS configuration like we all have had. And my personal example is a long time ago at one of my previous jobs, I was migrating DNS servers from one provider to another. And I was copying like the Route 53 DNS servers for multiple domains. And you see, for every domain, you have different DNS servers or name servers. But I was copying the one from the first one to all of them. And then you can just see how your DNS servers disappear over time. And the time to live is by default 24 hours. So at first it looks like everything works until stuff just suddenly starts disappearing. And the problem with the 24-hour time to live is it will also take 24 hours to recover because something will cache those bad values for you. So you helplessly watch as stuff disappears and you can only fix it and wait until it ages out. And since then, at that company, we had the policy that always two people would need to check like name server changes because otherwise very bad stuff happens. Next, TLS, which is kind of like the classic of how things are going wrong. And I had this problem recently where we wanted to do a Gradle upgrade. And there was an issue a year ago in November 21 where the TLS certificates on some Gradle servers expired. And Gradle just didn't work anymore for our dependencies. And then on that same issue there, it said, you see, November 21, and this is then November 22, the same thing happened again because like they added a TLS certificate that was valid for 1 year and it just hit the same problem hit exactly again. And it's just like a stupid problem to have another time. And we'll get a bit into how you can hopefully avoid that. And finally, bad configurations. Maybe you remember like more than a year ago, there was this big Facebook outage which took down WhatsApp and Facebook and Instagram, and it almost took down the entire internet, or at least for some people. And then there were these wild stories that they were using. So I think the problem was in the end, like they didn't properly announce the DNS configs, but the problem was actually a config issue in the background. The problem was they were running everything through DNS there, including the access to the server rooms. And there's this legendary story that they had to chainsaw into the server room because they couldn't open the doors anymore without the configurations working properly. So they had to physically force their way into the room to fix that one. And Cloudflare wrote a very nice post about that to explain that. However, Cloudflare had something interesting as well earlier this year where they were trying to make their infrastructure more resilient. And that worked for most of the small data centers, but their biggest data centers had a bug then and then went offline, which was especially tragic since they were trying to make their infrastructure more resilient than it had been before. Which then looked something like this, that they applied a change. The first red line is they applied a change to the small data centers, and then they applied a change to the spines, which is like their largest data centers. And then you can see suddenly their traffic drops to half. They figure out something is wrong. They roll it back, and then it slowly recovers. And this all to make it more resilient, which is a bit ironic, but that's, for example, what Cloudflare did. So how do you fight those problems? And I could almost call them the Horcruxes, right? DNS, TLS, and bad configs are like these things that keep coming back at us and attack and kill us. How did you fight the Horcrux? You needed to find the right tool, right? And Yeah, it's maybe magic. But even in Harry Potter, it was like you had a tool like the tooth of the snail, the snake, how you could kill a Horcrux. So how do we kill our Horcruxes in configurations? And my theory here is, and we can have a discussion afterwards about that, is that health checks are kind of like hopefully the Horcrux of like fixing those configuration issues. And how I would see it is, if you structure your health checks correctly, you can early on figure out what is going on before your users shout on Twitter and say everything is broken. Unless Twitter goes down now, but that's a different story. So you can structure them outside the network, on the network, or on the host. So what I mean with outside the network, let's assume we have our infrastructure is running on AWS. And then we want to have a health check from some other provider, for example, DigitalOcean or wherever else we want to have that health check coming from. And by pinging my service from the outside, I can check like, did I configure the right DNS servers? And are the DNS servers of my provider working for somebody else? Is the uplink of my provider actually working? Did I configure the firewall correctly here? Is the load balancer in front of my application of the provider working? Is my service behind it available? And what is the latency doing? So from those external pings, you get more the view from the end user of what is actually working or what is not working. Then you can make a health check within the network, for example, from one availability zone to another availability zone, where you check, is the network between availability zones working for your provider? Did you configure the internal firewalls? Is TLS set up correctly? You could have put TLS outside as well. And is the service available? So here you check from one availability zone to the other. And then you could even check on the host, for example, is the service available on the host itself? Or for example, if you have a local reverse proxy like Nginx, is the reverse proxy down or is my application down? And from my host, can I reach the external dependencies like a database? And based on where the health check is failing, you can then get a pretty good idea quickly what is up and what is not working. For example, if your application is generally up, but it cannot reach the database, and that's what is kind of like cascading the failure through your system, you could figure that out pretty quickly if you have these health checks to see, okay, you misconfigured the firewall. Either it's down or you misconfigured the firewall to access the database. Whatever it was, you could see that. Or for example, if the reverse proxy on the instance goes down and you cannot reach the service while the service is up, you can, based on the right health checks or where something is failing, you can see how things are broken or how they are not broken. And that will pinpoint where to start looking, because if your users shout something is down, that doesn't tell you much in like where to start looking. Whereas the right health checks can hopefully pinpoint the area that you need to research when something doesn't work anymore. Why do I talk about that? Obviously, we as a company have health check rules and tools. That's why I always believe that health checks are a good thing to have in your stack. So for example, what our health check rules could look like is you could check with ICMP. So this tool here that runs this is called Heartbeat, which is a health check thing. And I could, for example, say that is my demo domain, which obviously is WTF for any demo. And I could ping the instance to see if my instance is available on ICMP. Who likes cron? How often am I pinging here? Every 5 minutes, yep. And every 5 seconds, actually, I think.
There's no second.
Yeah, okay. You could, based on, if you want to make it more readable, you could also write it as something like this with a time unit. So for example, here, I'm checking is my MySQL and Postgres server available. This one is a TCP check because they don't speak HTTP, so I cannot do a higher level check, but you can just check is the socket on these default ports available. Or if you have something that speaks HTTP, you could do an HTTP check and say like, is the thing available on a status page? And then you could exclude that from the stats, for example. Otherwise, you would generate a lot of unnecessary traffic, or it looks like unnecessary traffic. What you can also do is you can monitor here or aggregate all of that. So you can see here, I'm monitoring 32 different things. And you can see most of them are up, but some are down. And you could see where they are down. and you could see the list of each one of them, filter then to see what is up and what is down. What is quite convenient here, for example, is if it's using HTTP and you're pinging an HTTPS endpoint, it can also tell you if the certificate is still valid or not and how long you have until it expires. And then obviously you could set an alert on that. And if you only have 20 days left on your certificate or whatever, it would send you an email, because that's a stupid problem to have if your certificates expire. And of course, you will always forget some domains here, and you will add them later on manually. Yes, please.
Check the entire chain.
The question was, are we checking the entire chain? So yeah, this is, I think it relies, since this is a Go binary, it relies on Go to check that, but I think it goes through the entire chain. So you mean if the certificate is also valid?
We had some issue, if you remember, 15 years ago when expired the root certificate of the promoter.
Okay. Yeah, so the comment was, if the root certificate expires, you have a problem. I think that will then rely on that you have the right time and everything in the checker, but that should check the full chain through for you. Because it's just the Go binary can also check if a certificate is valid from end to end. Yeah, no. It should check the entire chain, and you can see who issued it and how long it's valid, etc. So those are all set up here. You can also do something like a higher level check that you might want to add, where you could say, like, I'm not just getting a get or doing a get to get a response back, but for example, here I'm adding a product, for example, with a post. And then you provide some parameters to actually do that. In your application knows that this is a health check, so it shouldn't actually fulfill that order or do that thing. But you know that this should give you a 200 back, and the response should include saved, either in uppercase or lowercase s here. So this way you can actually check it more end to end. So you can actually know that this gets stored to the database correctly and you get the response back. So it's more than just a simple get, but really going more into the service, what you could do. And then there is the synthetic monitoring, which is like one of the buzzwords that everybody is chasing after nowadays. And depending on how old you are, I know that some of the people with gray hairs are saying, like, we've been doing this for 20 years. We just didn't call it that way. And the newer generation is more like, no, this is all new and exciting. And both, I think, are to some degree true. So what you do is you basically take a headless browser and you simulate the workflow that is happening frequently. So if the main thing is that you have a shopping cart and somebody buys something, your main flow would be you put something in the shopping cart and you go to the checkout page, and all of that flow works correctly. So the idea is you catch that before your users complain about it on Twitter. So you run through that flow every minute or so, and then it would tell you, oh, that flow that should always work just broke after the deployment. Maybe you want to roll that back very quickly, or somebody should take a look. So it's just to simulate the end user and give you more of an end-to-end perspective of how things are working. Playwright is the JavaScript framework from Microsoft that is very commonly used for that. If Cypress could be like an alternative for end-to-end tests like that, but I think Playwright is the new up-and-coming thing that many people are using. And I'll show you a bit what that looks like. So for example, here, we have wrapped that in the Elastic Synthetics, for example, but this is just Playwright. So for example, here I'm going to Xera WTF, and then I'm saying I expect a placeholder with input new to do, and then it needs to have that value, what needs to be done. And you can simulate the full flow, like adding something to a cart or checking out. And you can write that entire thing in code. And then it will give you a dashboard like this, where it says like, this is what the page looks like, for example. This is where you spend your time. So it does everything end to end, including DNS lookup, doing the connection, TLS handshake, sending the request, waiting for the data to come back. You also see how much data you're actually transferring, which is also like a good metric to check if you're not sending some stupidly large image back. And it also shows you what Google considers the general hygiene of the largest contentful paint, etc., to how fast your pages are behaving and if you want to make any optimizations there. So anytime you deploy, you can then quickly figure out if you made something worse or not over time, or if you broke something. If you don't want to write all of this by hand, because writing this code by hand is maybe a bit of a pain, Playwright also have a code generator where you could say, if you install the package, run Playwright and generate me the code from going to that domain, and then whatever you click together will be generated as code for you. You can take that, you can customize the generated code, and then you can just run through those automatically in the future. I think the main downside for this is if you change your UI a lot, it can get brittle and break a lot, and then you always need to adjust for that. So once your site has more or less stabilized, then probably health checks make most sense. So to wrap up, health checks are generally great because they're fast and they're pretty cheap because they don't generate a lot of data. They are not so great to tell you why something is broken. It's almost like the old discussion between observability and monitoring. Monitoring is telling you something is broken, but it doesn't tell you so well why. And health checks are also classically in that monitoring side. It tells you something is off, but it doesn't really give you all the context of what really happened. But if you structure them correctly, they should give you a decent overview of what is happening. Is it like DNS from the outside, or is it potentially the firewall on the outside that is working or that is broken and your service is working fine on the inside? Or is the service actually down and that's why nothing else works? So it could pinpoint pretty exactly where things are failing for you. And then you can dive into that specific part. And then you probably need some better observability tooling with logs, metrics, traces, or whatever else you have to pinpoint why something is broken. But it should point you in the right direction where such stuff is broken. A bit like in Harry Potter, where you always need to follow Ron, Hermione to see what is up and what is broken. And synthetics are a nice addition to add, but only add them when you need them or when you can afford them, because they're more work and they are a bit more brittle in terms of breaking if you change your site. But you can just manually, or you can just add them when you're ready for that. That's it. We have 1 or 2 minutes for questions. And before you go, I always try to take a picture with you so I can prove to my colleagues that I've been working today. You know, as you can hear, I'm not from around. And my colleagues don't really know where I am. Can you all wave? Thanks a lot. Any questions? I think we have 1 or 2 minutes left, right? Who is already using health checks? Just for quick indicator. Okay. Yeah. Who is using synthetics? That's far fewer. Who should use health checks and isn't yet? Okay, that's also a lot of people. Any final questions? No? Thanks a lot for having me.